Hi, my name is Etienne Caron, and I'm Head of Engineering at Canestruc Consulting Services, where we specialize in Kotlin Multiplatform development. Today, I'll be showing you how to build a user editor profile app using Firebase on the server side and Kotlin Multiplatform on the client side. Firebase is great for user management because it makes things really easy. After selecting your new project in the Firebase console, jump to the Authentication section. Under the Sign-in Method tab, you can configure sign-in providers. For this example, we'll only enable the anonymous provider. That allows us to create a new Firebase user with zero friction. Anonymous access also lets us save data during the registration process. Obviously, it's possible to upgrade that to a more permanent access once your users will register with their email. But we won't cover that in this video. We need a place to store the profile information we're editing today. So go to the real-time database section and select the Rules tab. To limit potential abuse, we'll only allow authenticated users to write to user contact and user address. You might wonder why I'm splitting the user's contact info from their address this specific way. So the idea is that with Firebase's real-time DB, you want to keep structures flat and you want to avoid nesting them. So that helps when you're writing security rules, and it also tends to make data transfers more efficient. Now, that's worth a video on its own. So if you want to find out more, look for documentation links in the comment section below. Now, that's all we needed on the backend. Let's start with our two front-end modules. One is an Android project, and the other is a JavaScript web application. The goal of our multi-platform project is to share as much code as we can between these two apps. So for this example, I ended up with 3 distinct library layers. The bottom layer is for low-level common code. So in my project, I called it libshared. I think of it as a toolbox for my next layer called liblogic. Liblogic is where I'll put all of my business logic and the code that can be safely abstracted away from the target platform. If some of my business logic ends up depending on a platform-specific library, that code will be living in the next and final layer, the platform-specific library layer. So let's go over each layer in turn, and I'll explain the reasoning behind each. In the Gradle file for the libshared module, I start by adding the Kotlin Multiplatform plugin. That plugin allows us to declare multiple source code sets. So we're going to configure 3 different sets. The first one is the common source code. Common code is non-platform specific Kotlin code that can be called from any platform. We'll also configure an Android source set and a JavaScript source set. For libshared, that's where the platform-specific implementations of the code will live. Libshared is a low-level toolbox for liblogic. As an example, say we need a simple error logging function, something like log e takes a message. In JavaScript, we would implement this by calling console error. On Android, we would use the log e function. You can see that error logging is going to be very different from one platform to the next, even though it's very simple. Kotlin gives us the expect and actual keywords to deal with this problem. With these keywords, you can tell Kotlin that you'll actually be calling a platform-specific version of a function for a given expected function. We can use expect and actual on most Kotlin declarations. It works for functions, classes, interfaces, enumerations, and it also works on properties and annotations. I've added links to JetBrains' own page on that subject, and also a link to a great blog post from TouchLab. They're one of the leading companies in the multi-platform mobile space, and they have a lot of great content. So am I recommending we use expect and actual everywhere? In fact, no, not at all. The documentation found on JetBrains' site says it best. Use expected and actual declarations only for Kotlin declarations that have platform-specific dependencies. It's better to implement as much functionality as possible in the shared module, even if doing so takes more time. Don't overuse expected and actual declarations. In some cases, an interface may be a better choice because it's more flexible and easier to test. And for me, some cases ended up being most cases, quite honestly. One of the reasons expectedactual is kind of tricky to use is that the IDE support is not up there yet. It's a bit broken. Well, to be fair, Kotlin Multiplatform is still in alpha, right? But like documented here, the most compelling argument against using expectedactual is actually that interfaces are more straightforward. Let's jump to our liblogic module now to illustrate the use of interfaces in common code. Note that the Gradle file won't change much. The main difference from the one I showed you for libshared is that all our code will now live in the common source set. Data classes can be a good low-hanging fruit for code sharing. So here we start with two simple data classes, address and contact. Next, we'll look at a bit of business logic. I've personally picked an MVI architecture, but you should be able to adapt this example to your own favorite without too much trouble. Most modern architecture patterns will depend on coroutines and flow in some way. So Kotlin's standard coroutine libraries are available from the common project scope. That's really great, because that means we can develop the bulk of our domain and business logic in the liblogic modules common source set. Let's start looking at more serious business logic code with a user profile editor model class. This class allows our UI code to edit the user profile properties and eventually save them to Firebase. Working with a document metaphor here, I gave our editor 4 top-level states: closed, opening, editing, and saving. The model is closed when we're not using it. We can then open that model. That will move the model in an opening state while waiting for Firebase to return our requested user profile data. Once we have the data on hand, we'll switch to an editing state. While editing, we keep a working copy of user profile in memory, and we apply user edits to that copy. Once our users are satisfied with their changes, they'll hit save. We launch a background save coroutine at that point and transition our model into the saving state while waiting for that coroutine to complete. When Firebase has saved the information, we finally move back to the closed state. Firebase has SDKs for Android, iOS, the web, and more. So when we write a function to load or save a user profile from Firebase, we need to have a platform-specific version of that code. If you've paid very close attention in the last minute or two, you might have noticed the following bits of code in the save and open intent. This is where our interface-based approach is going to kick in. So the interface is called FBServiceModel. It has 2 functions: load user profile and save user profile. These are both suspending functions. So when the model lands in the opening or saving state, as we've seen, we're waiting on the load profile or save profile functions to complete. These 2 states allow us then to foolproof our editor. When we start the saving or loading calls, we transition the model to the appropriate state, and the model can wait on the suspending functions to complete before processing any other type of view events. Let's look at the Android version of FBServiceModel. Load profile here uses the Android Firebase API to grab our UID and makes parallel async calls to fetch all our data. Now, as you can see, we're doing something very similar to the save user profile function. I used Compose to whip up a quick and straightforward Android example app. My Compose UI will show an edit user profile button when the editor is closed, a progress indicator while loading the data, followed by the editing form itself. Finally, when the user clicks save, we transition to the saving state and we're done. Jumping to the main activity, we can use the dependency injection of our choice to get a copy of the editor model. The Compose code flipping between these states is simple. We call collect as state on our state flow. The when clause will force us to handle all possible cases. Now note the use of an emitter function here. We use it to emit the view event signals back to our model. Alright, let's jump over to the JavaScript implementation. First, we're going to need to implement the JavaScript version of FBServiceModel. Looking at load profile and save profile, we're very close to the Android version. Things only really start diverging when we try to safeguard our typing system. Still, I suspect I could improve the code sharing here. Might be worth a follow-up episode, but for now, I'll leave it up as an exercise to you, dear viewers. For my JavaScript UI, I decided to keep things simple and I used Bootstrap for my example. I considered using Compose for web. Super interesting project, but it's simply not ready for real-world use right now. So, also note how the UX flow is identical to the Android version. We open the profile editor, change fields, save, etc. In the code, we have a main function instead of a main activity. We create an editor view and attach it to the model, updating it every time that model changes. And when the user interacts with this view, view events are dispatched and converted to intents, which are then processed by our model. One thing that surprised me is how I managed to actually reuse the same user profile view events and dispatchers for both platforms. So that worked really well, mostly because I kept my UX very similar here between the two platforms. Both are using an edit in place, save, cancel button type of layout. So I might not have been able to do that if, say, my layout or navigation was radically different. Well, that's it for this quick introduction to the wonderful world of Kotlin multi-platform programming. Today we learned how to structure a starter project, how to structure our code modules for maximum reuse, and we also saw a comparison between the expectedactual approaches versus the simpler interface implementation approach. We also saw that a well-designed logic library can easily be connected up to very different client platforms and APIs. Well, that's it for this small intro to Kotlin multi-platform programming. I hope you enjoyed it. Now, you'll find the code for this application available on GitHub in the address below. Thank you for your time. This is Etienne signing off. Have a great day.